Live. Okay. This is the last bit for complex numbers. All we have to do right now is to graph our complex numbers, which remember have a real component and an imaginary component, right? Okay. So just as a usual coordinate grid has our x-axis, our y-axis. Now all we're doing is defining the y-axis as our imaginary axis. Our y-axis is where we're going to note our imaginaries. X-axis is for real. Okay. Now, this isn't too much further in the topics you've covered, but I also want to cover absolute value of our complex numbers, because this is going to help us understand what's called vectors. Vectors are a topic we're going to get into very soon. Okay. So, here's the deal. I'm sure if I give you this breakdown, you'll be able to do this. You're going to make your pair from your complex number. The real always goes first. The imaginary always goes second. So let's go ahead. Let's make our points. And then I want you to just quickly graph them on our grid we have here. And when you're doing your grid, you don't have to be perfect. If you had to go to like 17, I don't want you to go 1, 2, 3, 4. I don't want you to do that. Wait. Pausing it, unpausing it. Yes. Okay, was this pretty quick? You guys see how these are going to be quick to knock out, right? You just take it, the first one. Which one's my real? 3. 3 goes in where x used to go. But I'm just doing the real and the imaginary as my new point. Positive 4i, 4. That's it. We don't put the I because we know in this case the y-axis is denoted by our imaginary numbers. So let's go ahead and just fill in the rest and then see if you can start to plot them. You need to wait for when we do it together. So my second one, -4, 2, -4, 2. And that should be enough to confirm the route we're going with it. So get all those in, graph them real quick. Graph them real quick. Okay, let's fill these in real quick, all together. You can fill them in as we go. We'll do the points together too, so you can fill them in. Okay, so 2 minus 3i, point? 2. -3. Okay. 3. What's my real part? What's my imaginary part? Good. You guys caught that, right? 3, 0. Okay. 4i. It's kind of the opposite. 0, 4. Okay. Thumbs up, sideways, down for just, this is how the points work. Graphing, is it going to be any different, really? Is it going to be harder or easier than graphing regular points? Same, right? We just had to learn this definition. These are my imaginaries. Here's my x. Or in this case, real. Okay, 3, 4. 3 for x. 4 for y. 3, 4. Right? Let's see, -4, 2. Didn't even make it far enough. -1, 2, 3, 4. Up to, here we go. -4, 2. I'm doing quick because there's really no mystery to it. 2, -3. 1, 2. Down 3. 2, -3. 3, 0. 0, 4. All right, still all thumbs up. We can graph these, right? Right? If you need some refreshers on graphing, that's something to come in for lunch for. Okay. I also labeled this as the capital C with a little cursive sign. So sometimes we have to label the plane. In this case, I labeled it C because it's a complex plane. Yeah, that's more like logistical stuff. All right. Now next, this is what we have next. And this actually isn't so bad. It's not so bad. We're going to find the absolute value through the graph, using the graph. Okay. Now, you may have seen absolute value seen as the distance from 0. You guys heard of that before? So that's why it's always positive. If I just have a number line right here, here's 0. If I'm at -7 here and 7 here, how far is it between 0 and 7? 7. How far from 0 to -7? 7. It's in distance. It's asking, how far are you from 0? How far are you from 0? If you're at -100, how far from 0? 100, right? That's why absolute value is always positive, because the distance has to be measured in positive values. So distance from 0, that's pretty straightforward. We've heard that. Magnitude is what I want to introduce today. Modulus, I just thought was a cool word. I hadn't really heard it said that way. So modulus is another way to look at it. But magnitude is the main thing for today, because it introduces vectors. Now, a vector is no big deal. A vector is no big deal. If you have a vector, essentially, where it's going to go next year is, we always start from this axis here, and we would rotate up a certain theta. Okay, we're going to learn this next year. I'm just showing you where this is coming, where it's going. The magnitude is this distance. How far from the origin? How far from the origin? So that's our magnitude. So really, all you need to know, right? All you need to know if you're using vectors is how far you open your angle and how far out it is. Could you aim at this point right here using vectors? What would you have to do? You'd have to open up to about here, and then you'd be able to graph it. So theta is just, when we don't know the angle, we call it theta. But all this is saying is, we are finding the magnitude for our point that we have up here. Now, keep that in your mind. If we look closely, we really just have a triangle here. It's B, height. It's A, width. Because, I know here's my triangle, your point is going to tell you how far over and up you go. Okay. So if I have this point up here at AB, I could find the absolute value finding the magnitude right here. That's essentially finding our C value. Pythagorean theorem, like this. If I solve for C, I just take the square root of both sides, and that's where we get to our equation we're going to start with. Right here. Okay. Let's do this example, 3 plus 4i. I want you to graph that real quick. 3 plus 4i, first find the point. Graph it, and then we'll work on finding that magnitude, the distance from 0. Because, look at that. Think about it. The absolute value is what? The distance from 0. If I'm right here, what is the quickest and most direct route to get to 0, 0? The magnitude. You see?
Okay.
Let's see. I call this point 0, 0. And up here is a point 3, 7. From my definition I just gave you, absolute value is the distance from 0. So if I look at this example here, here's my point. The distance from 0, what's the quickest route to go from one point to another point? Is it to do a big curve? Is it to go out then in? Or is it to go straight at it? Straight at it. So this distance is my absolute value. The absolute value for this point is the distance to 0. Just like with our number line, -6 is 6 from 0. Same idea. So if I make my triangle like I'm going to do over here, I know that's 7, I know that's 3. Now I could find that distance, Pythagorean. So this 3 plus 4i is 3 and 4. So I know it's approximately up here. I want to find the magnitude. I know that's 3, that's 4. So I want you to use Pythagorean and go to find what that magnitude is for that example problem. It's a Pythagorean triple. You might recognize it. You see it? A bit. 3, 4. So we have our absolute value of z. 3 squared plus 4 squared. 9 plus 20. In the future. Square root of 25 is 5. Now, remember that we're talking about a magnitude. Can this distance right here that I'm highlighting, can that be negative 5 distance? No. Nancy absolute value was saying, what is just the distance from 0? This point here, if I turn the arrow around, maybe it's more helpful. This point here that we have, 3, 4, is 5 distance from 0. This is 0 right here. It's the same thing as when we had the number line up here. All it is we're going to the origin. Right? Thumbs up, sideways, down. I feel like it's a mixed bag. Okay. Here's the deal. The explanation, if that helped you to see what vectors are, it's going to be helpful in the future. If all you know you need to do is find the point, plug it in here to find your absolute value, that will also work. I did a lot that's kind of like, what's next? Okay, guys? So don't worry so much. You won't have to explain this. All right? So we got thumbs up. We got some sideways. Not bad. Is there anything we should inform the people at home about? Well, I have about 230 now, so that's right. I've been doing some marketing online. There was someone online that was actually, I'll leave that out. I'll take that out. How about just subscribe on 3? As loud as we can get it. Let's wake up next door. All right? Subscribe on 3. 1, 2, 3. Subscribe! That's pretty good. That's pretty good.